All right, let's look at implicit differentiation of inverse trig functions. Let's say we've got y equals sine inverse x. So we want to find dy dx. This is how we're going to go about doing it. They do this in 3.7. 3.7 has derivatives of inverses. It is very confusing. It is terrible. Terrible. If you read it, don't ask me questions about it. I don't use it, and none of the teachers here really use it. It's a terrible section. The only time we're really taking derivatives of inverse functions is on inverse trig functions, and there's a better way. So let's say we got y equals sine inverse x. We're going to rewrite that using the inverse relationship, and we're going to draw the corresponding triangle. I've got sine y equals x. So you just swap the variables and change it. And x is the same thing as x over 1, which is for sine is opposite over hypotenuse. I drew that two ways because sine inverse is restricted between negative pi over 2 and pi over 2. The angle, y is an angle here. And so I drew the triangle two ways. Because it could be positive or it could be negative. We don't know which way it is. You kind of want to do this for all the trig functions you do, as we'll see in a second. Then I solved for the missing side. With the missing side was square root of 1 minus x squared plus or minus. And so I did the two different versions, one above, one below. So we've got sine y dy dx. This is where I'm at right here. I'm right here. We're going to take the derivative with respect to x. We take the derivative of sine y. We get cosine y dy dx. The right side is 1. We're solving for, we want dy dx. That's what we're looking for. So we're going to divide by cosine y, and we get dy dx equals 1 over cosine y. Okay? And now go back to your triangle and figure out what cosine y is. We are going to take advantage of the fact that cosine y, since it is cosine is an even function. So cosine of negative y is equal to cosine y. So it doesn't really matter if I do y less than 0, where we're doing the negative pi squared, or not pi squared, negative pi over 2 is less than or equal to y. That's the same thing. It doesn't matter which one we do, we can still use the positive side. We can ignore the negative version is where I'm going with this. So we're not going to bother with doing the negative square root of 1 minus x squared. We're going to have positive. So cosine y is adjacent over hypotenuse. From the triangle, adjacent is the square root of 1 minus x squared. Hypotenuse is 1, so cosine y, after you get rid of the fraction, because dividing by 1 doesn't do anything, we have 1 square root of 1 minus x squared. That is what's going right here. So dy dx is 1 over cosine y, which is 1 over square root of 1 minus x squared, if y equals sine inverse x. Okay? You try, and I made it a little bit trickier. We're going to do tangent inverse, but I got 3x squared on the inside. It does not change the process. The process is the same. I recommend pausing the video and trying this. Okay? Change it over so you have tangent y equals 3x squared and go from there. Draw the triangle. Okay? So I rewrote it. I've got 3x squared equals tangent y. Tangent is opposite over adjacent. So when I did the picture, I got opposite is here, adjacent is here. When I solve for it, I get the question mark is square root of 1 plus 9x to the 4th. And we'll go back to that in a second. We take the derivative of both sides, we get 6x on the left. On the right side, we have secant squared y dy dx. We isolate dy dx by dividing by secant squared y. So dy dx equals 6x over secant squared y. But 1 over secant squared, or 1 over secant theta is cosine theta. So we took advantage of that to rewrite this as 6x times cosine squared y. Okay, so we go to our picture, we go to our triangle. Cosine y is adjacent over hypotenuse. Adjacent is 1. The hypotenuse is my question mark, which is 1 plus 9x to the 4th, the square root. So we plug that in, and cosine y was getting squared, so we got dy dx equals 6x times the 1 over square root of 1 plus 9x to the 4th. We're going to square that, just gets rid of the square root. Dy dx equals 6x over 1 plus 9x to the 4th. Okay? We did this without using the chain rule. The chain rule is not required when you do implicit differentiation and do this triangle thing with trig functions. Let's like the book is going to give you 6 formulas for the 6 trig function, the inverse trig functions. They're going to give you a formula for doing it. So how do you do it when there's a chain rule applied? Let's go back to the y equals sine inverse x, and then we'll look at this y equals tangent inverse we did again here. Y equals sine inverse x. We're going to compare that to y equals sine inverse g of x. So wherever there was an x in our dy dx for, this was what we had for y equals sine inverse x. That's not what that looks like. Y equals sine inverse x led to dy dx over 1 over square root of 1 minus x squared. Everywhere we see x, we're going to replace it with g of x. And then chain rule, we got to multiply by g prime of x. Because remember, when y equals f of g of x, y prime is f prime of g of x times g prime of x. That's what we're basing it off of. So I had the x here. I'm going to put the gx here. It's going to get squared. Then we multiply by g prime of x. So we could do this for like sine inverse 2x to the 4th. We're gonna using the formula, the g of x here is 2x to the 4th. So we're gonna put that in parentheses and the square root on bottom and square it, and then we multiply by the derivative of it. So when we square 2x to the 4th, we get 4x to the 8th. So the bottom is the square root of 1 minus 4x to the 8th. We're multiplying it by the derivative of 2x to the 4th for some reason. No, that's right. 8x cubed. And then instead of leaving them as separate things, I put them together. 8x cubed is on top. How does this translate over to tangent? What we did up here, you'll notice this 9x to the 4th. We started off with 3x squared. 9x to the 4th is 3x squared squared. We'll see this down below when we're doing the tangent inverse. So tangent inverse, up here we had 6x on top, but I had 8x cubed on top right here with my sine inverse. So that's probably coming from the chain rule. The tangent inverse function, when you take the derivative, it's 1 over 1 plus g of x squared times g prime of x. So if we were to go and do that y equals tangent inverse of 3x squared using the formula, we got dy dx equals 1 over 1 plus 3x squared squared, and then times dx of 3x squared. The derivative of 3x squared is 6x. That'll go on top. The 3x squared squared is 9x to the 4th. We put it all together, and that's the derivative we had up above. So, like I was telling you, the book has 6 formulas you can memorize. They are a pain in the ass. They are confusing to memorize. There's absolute values in some of them. But doing this triangle like we did up here with tangent inverse of 3x squared works every time. You flip it, you use the inverse relationship, draw the triangle, take derivatives, and go forth from there. Okay, that's how we're going to do it. I recommend not using the formulas for inverse trig functions and the derivatives. Just use implicit differentiation and practice that. It will be more helpful to you in the long run. If I ever have to do a problem with the inverse trig function, I don't remember the the formulas. I always do the triangles. All right, that's it for the videos. Peace.